Look at it yesterday. We talked about how you can actually solve these. You have to put it into an exponential format. What is the exponential format? Your base is 8. The exponent is 4/3. And the answer is n. So to solve, this 3 means you're taking the cube root of 8. What is the cube root of 8? 2. And if you raise that to the 4th power, 2 to the 4th power is 16. You should have 16 for an answer. Now, the only thing we talked about is when we talked about an inequality, that changed things just a little bit. And for some of you, you got to be careful if you put the base exponent first, what do you have to do to the inequality sign? Flip it. If you put the answer first, then the base and the exponent, what can you do to it? Keep it the same. So I don't care which way you work with it. Your base is 5, the exponent is 3. You flip the sign, and that's equal to your answer. Yes, I would prefer that you make that 125. So 5 cubed happens to be 125. X is greater than 125. Now, some of you tried putting in the 0 with that. You don't have a 0 unless it's less than 125. If it's greater than 125, you don't have a 0 at all.
If it's less than 0, you say 0 is, or X is greater than 0.
It's got to be greater than 0 because your answer has to be greater than 0. 5 to a power, there's no way you will get a negative value. And I know glancing at this, I saw just a couple of you that had that 0 less than or whatever 0 in there. So we just need to be careful of that one. I believe a good example of that worked with this one that you had yesterday as one of your practice ones that you had to do. So the first one is you look at the first one, your answer has got to be greater than base raised to the exponent. Now others of you, if you say your base raised to the power or your exponent, then you got to flip the sign and put your answer. Either one of those, 4 to the 3rd has a value of what? 64. So X has got to be greater than 64. But when you get to the second one, on the second one, what is your base? 2 raised to the 4th power. You're going to flip your sign and then you put your X. Or you say your answer is less than your base raised to your power. What is 2 to the 4th? Let's try 16. 2 times 2 is 4, times 2 is 8, times 2 is 16. This says it's got to be less than 16, but you can't have negative values. This is when you go ahead and put in, it's got to be greater than 0, but less than 16. And this is the way that they prefer you write it. You've got to have your smaller number to the left. X is in the middle of the smallest number of 0 and the largest number of 16. So you put it in between the two of them. It doesn't work as well when you try putting in another 0 in here somewhere. So the difference between the two inequality symbols that you have. All right, since we didn't get the John Baylor books until right now, I might watch just a little video clip, but it's the 3B video that you watch is part English and part math. I think I've got it stopped about where the math starts. So we might get to that, but I do have just a couple more examples I want to go over with you first. So if we look at it, there's another thing when you deal with logs, and it says if b is a positive number with your base, we know the base has to be a positive number other than 1, because 1 to any power is just going to give you 1. Then log base b of x is equal to log base b of y only if x is equal to y. That's the only way two log statements are going to be equal to each other, if they're in the same base. So if I look at this right here, it's saying log base 7 of x is equal to log base 7 of 3 if and only if those values are equal. So what does x got to be? 3. Those values have to be equal in order for them to be equal to each other. So if we look at another example, if I ask you to solve this one, log base 5 of p squared minus 2 is equal to log base 5 of p. The same base. So if the same base is equal, then these two are equal if p squared minus 2 is equal to p. Now that puts us into a quadratic. And into a quadratic, yeah, we've already got what the answer is. What is the answer? We see a 2. This, what? Oh, because 2 squared is 4, 4 minus 2 is 2, which is p, which is 2, which you told me it was. There's different ways we can solve a quadratic. So you're, do you have any clue on how to solve that? Besides just thinking of it and realizing 2 works.
I just moved the 2 over. But I just plus 2 over there.
When you solve a quadratic, we're going to have p squared. Actually, set it equal to 0. If I were to set it equal to 0, I'm going to move the p over, and it looks something like this. That's a quadratic. A quadratic means that your highest exponent is going to be to the second power. Quadratic, when you look at the graph of that, it's going to give you a parabola, which is like a U. Now, the ways that you can solve that is you can factor. In order to factor, we need to look at 2 binomials that when multiplied together, when you multiply first, outer, inner, last, is going to give you this value right here. When you factor, there's different things you look at. You're going to look here and you're going to say, oh, when I multiply these 2 numbers together right there, I have to get that 2 right there, a -2. Yes. No, you cannot have p, you cannot have p squared minus p equals 2. Why? Because you're going to be missing some values sometimes when you do that. There's actually 2 values you get for this, just one of them rules it out. When you talk about a parabola, when you're solving this, you're looking for intercepts, x or y intercepts. You're really looking at x intercepts for this one. And we talked about x-intercepts a little bit yesterday when we looked at the graph. And if you talk about an x-intercept, there is a possibility with a parabola that you can have 2. So when you start to get to a square, you run into the risk of having 2 solutions or 2 values that actually work. And when you start looking at it as solving it, like Trista was mentioning, you're going to get one, but you're going to forget the other one. Okay, so you can look at it as solving it by factoring, or the other way you could look at it is the quadratic formula. The quadratic formula is x equals -b plus or minus the square root b squared minus 4ac all over 2a. So that's the way we can find our solution. How can we do that? You look at the coefficients. The coefficient of p squared happens to be your a value, which is understood to be a 1. The x coefficient of, or the p coefficient in this case, of whatever your p coefficient is, happens to be b. In this case, it's a -1 because you got to take the sign that's with it. And then this last term, or your constant, happens to be your c value. So if I were to substitute that in this equation, a has a value of 1. So I'm going to go back and change this a and this a to a 1. So we get 1. We get 1. And then what does b have a value of? B is -1. But when you substitute that value in, it kind of changes this one into a +1. And then c has a value of -2. You could just type that in your calculator as stands, or you could say the opposite of -1 is 1 plus or minus the square root of -1 times -1 is 1, -4 times 1 times -2 is 8, all over 2 times 1 is 2. What? It is positive 8. Yep. So if you type that in, what you have is you have 1 plus or minus the square root of 9 over 2, which is 1 plus or minus the square root of 9 has a value of 3. The only thing you're going to have on your calculator is you're going to have to type it in twice when you do your fraction. Once is a positive, and then you can arrow up on your graphing calculators and enter it back in and change it to this negative sign right there. But what is 1 plus 3? So your two answers are 1 plus 3 divided by 2. That's 4 divided by 2, which is 2. And that's an answer that Trista was talking about. The other answer you can get is 1 minus 3 divided by 2. What is 1 minus 3? Negative 2 divided by 2 is negative 1. So if I come back up to this equation that we had that Trista said, well, your answer is 2 right here. She's saying P is equal to 2. But what about the value of negative 1? What's negative 1 squared? 1 minus 2 is what? Negative 1. Is that a solution? Does that make that a true statement? Yes, it does. But the thing that we have, I mean, it makes it a true statement. But the thing that we have to look at, so P equals 2 and P equals negative 1 makes that a true statement. Just a minute. Yeah, I said 2 and negative 1 make it a true statement. But when you deal with logs, we said something about this. When I take 5 and raise it to a power, is there any way this answer is going to be a negative value? No, 5 raised to any power is not a negative value. So because of it being a log format, that rules that out as an answer, and your only solution is P is equal to 2. So before we continue with some of this, I want to supplement some material with you on solving some quadratics. We're going to look at quadratics. But for the rest of the day, I know I'm going to look at we will look at the first John Baylor. I don't know, we'll have to look at the binders and see what you have. I was going to pull a few things out of there and then just hand it to you, but for right now, what I want you to do, oh, did you have a question over that, Eric?
I did.
Okay. All right, so what I want you to do right now before we continue on with some of this stuff, since I did have John Baylor planned for today, and she brought the binders in right when class started. So I want you to, are your binders, have your names on them? All right, so if you could find your binder, please.